Here we have an optimization problem where we need to minimize the distance between 2 points. One point is known at 1, 0. The other point is some other mystery point, x, y, along the equation of the line y equals 2x. I represented that by that purple coordinate there, x, y. Since we need to find those coordinates, it's helpful to use the distance equation where d, the distance between 2 points, is equal to the square root of x2 minus x1 being squared plus y2 minus y1 squared. The difference in x coordinate squared plus the difference of y coordinate squared. Let's substitute the second x coordinate. If I pick that as the x from the purple point, then my first x coordinate is 1 squared plus the second y coordinate, I'm going to pick y, minus the first y coordinate, 0 squared. And I'm going to rewrite this as x minus 1 squared plus y squared, all to the 1/2 power, since the square root is represented by the 1/2 power. Those are equivalent. Next, let's take the derivative of the distance equation with respect to x. We bring the 1/2 down, multiplied by the unchanged inside part, the part inside the bracket, x minus 1 squared plus y squared. Subtract 1 from the power and get negative 1/2. Don't forget to multiply by the derivative of the inside part. 2 times x minus 1 to the 1 multiplied by derivative of x minus 1 is 1, because we're doing the derivative with respect to x, plus derivative of y squared is 2y, multiplied by the derivative of y we need to represent as dy dx, since y is an implicit function in terms of x. Next, I'm going to rewrite this with the numerator here. The numerator is just the 2 times the x minus 1 plus the 2y dy dx all over. There's a 2 in the denominator from the 1/2, and the other term, which had a negative exponent, flips over to the denominator. The 1/2 is represented by that square root of x minus 1 squared plus y squared. And next we will take this derivative, set it equal to 0 to find the local minimum. Let's work only with the numerator. We only want the numerator equal to 0, since the denominator can never be 0. That'll be an undefined value. So the numerator being the 2 times the x minus 1, I will distribute the 2 there, call that 2x minus 2, plus 2 times y, but I want to rewrite y in terms of x since we know y equals 2x. I'm going to substitute 2x in place of that y, so we have only one variable we're working with. Then we want to multiply by dy dx. We can find that as well. Since we know y equals 2x, the derivative of y with respect to x is equal to 2. So we can substitute 2 for that dy dx. Here we have an equation we want to solve. And I'm going to simplify this equation here. We have a 2 times 2x, 4x times 2, 8x, plus another 2x makes 10x. Minus a 2 set to 0. And if we add the 2 and divide the 10, we're going to get x equals 1/5. If x is 1/5, there's the x coordinate we just found for the point we were trying to solve for. And then if we plug in x into the y equals 2x, we can find the y coordinate as 2 times 1/5, which will give us 2/5. And verify that that point is indeed a point on the equation of the line y equals 2x, and it's satisfied where the derivative of that distance equation is equal to 0. You can also verify that that is a local minimum value from that distance equation.